Okay, so good afternoon once again. My name is Adibayo Bukola. I'm a data scientist that I work with data scientists as well. Welcome to the second session of Geospatial Analysis for Businesses Using QGIS. So before we go deeper, I would like to have a recap of the last class. Okay, so if you joined us the last class, you will realize that this is a continuation of the last class, which is based on vector analysis. So if we deep dive into last class, so first we introduced spatial analysis, which is what spatial analysis is about, the definition, the use case, and the application. Then we move into different types of data, spatial data, where we have the vector and the raster data, and we also show how to use vector data to clip, reprocess basically, and analyze the data. Okay, but before we go there, we showed us how to use some GIS tools, which is the programmatic GIS and the GUI, which is the graphical user interface. So for programmatic GIS, we have Python and the R basically used for GIS. But for the GUI, like I said, the graphical user interface, which people mostly call drag and drop. So we used QGIS for that. So we dove into QGIS a bit and we showed how vector data have been added to QGIS interface, and a little bit of vector preprocessing tools such as clipping, buffering, and co. Then we also did a little bit of vector analysis. So all these we learned, we used it to analyze the business use case on how a company can situate its ATM or POS withdrawal businesses around Lagos State. So we used the market data, which is where markets are located in Lagos State and how frequent markets open and all other properties of the market to get this visual you're looking at, which translates into the market activities by local government. And it was divided into local governments with busy markets, very busy market, and not so busy market. So these will give the company an insight on where to situate its POS withdrawal business.
There, you're muted. You're muted.
Okay, so apologies for that. So for this week, we'll be focusing more on raster data and its analysis. So we'll be focusing on what raster data entails, then raster, how to add raster data to QGIS, and the pre-processing of raster data and analysis. Then we'll also focus on use case scenario raster data, which will make use of what we did last week also. So we are going to combine vector and raster data for a use case scenario this time around. Okay, now that we've gotten the introduction out of the way, let's delve into the real business. So, what are raster data? So, I believe you've been hearing about raster data. Raster data, you might not know what it means or what it entails. So, So raster data are just digital area. Raster data are actually any pixelated or graded data where each point of the pixel is associated with a specific geographical location. So what do I mean by this? For every raster data are like image, like basically image data, and for every raster data is always stored in pixels. That's like in a cube, in a square shape. So what you are looking at here is a pixel. So for each cell here, we call them cells. It refers to a pixel. So it's always stored in a square format or a square shape. And raster data can be digital area photographs, imagery from satellites, digital pictures, or even scan maps. So let me show you examples of raster data that we have. So we have climate and weather data. There are also examples of raster data. This is because if you take the raster data of an area or a geographical area and you store the data today and also tomorrow, so it changes with time. And you can also use that data for time series analysis. Also, we have land cover data and we have population data. Most times, we usually use population density data. So this is the population of a particular set of people in an area. So when you talk about population density, I believe we've all heard about population density before, so which is just the population divided by the area. Then we also have digital elevation model data, which is DEM data. So it's used to show the topography of the earth. Examples are mountains, valleys, and areas like that. Okay, so spatial resolution. Before we move on, we need to know what spatial resolution is. I think I mentioned it earlier. Raster data stored in pixels. So spatial resolution refers to the size of the raster of the cells in the raster data and the ratio of the screen pixels to the image size and the current map scale rather. So what you are looking at, the image you are looking at on your screen is an example of a spatial resolution. So you can see to your left-hand side, you can see high spatial resolution, medium spatial resolution, and low spatial resolution. So for each image you're looking at, each consists of pixels. Pixels that are made up of raster data. So the higher the number of pixels in a spatial resolution, the lower the resolution. So what do I mean? The higher spatial resolution you're looking at consists of 30 pixels, while the medium consists of 100 pixels and the low consists of 100. Sorry, the medium consists of 60 pixels and the low consists of 100 pixels. So it's just a try for you to understand how spatial resolution works. So the higher your pixel, the lower your spatial resolution. Okay, so I believe we've gotten that out of the way. So I will just move into the practical application of spatial data right now. Sorry, raster data instead. So I'll be taking us back to our QGIS stuff in the last class and we'll move on from there. Okay. Um, so I want to believe by now you have your QGIS on and it's on your system. So I don't know if this is going to be a follow-up or you rather wait for me to do this and you try it on your own. So either way, so once you've opened your QGIS, you need to learn how to load your spatial data into QGIS. So, but before we go into loading your spatial data into QGIS, you don't just get your spatial data like that. You have to go into sources to load your spatial data, to get your spatial data. So there are different sources of spatial data, raster data rather. There are different sources of raster data available online. So one of them is WordPop, and let me just show you how to get the data from WordPop before we move to QGIS. Okay, so you can just go to your Google and then type WordPop. That's WORD and pop. So because I have it on my history, so I just go to the data catalog. But for those of us that don't have it, I just search for WordPop and go to WordPop. So on WordPop interface, you can see the about us, methods and tools, data, news, projects, contact us, and information about COVID-19. So what we are looking for here is to extract data, how to get our data from WordPop. So you can either use this expand and access WordPop data sets, or you use data to access the data bank in WordPop. So you can click on the category you wish to explore. I'll be going for population density. So you can either go for unconstrained individual countries between 2000, year 2000 and year 2020, or unconstrained individual countries, which is UN adjusted, and it's also in 1 kilometer resolution. So 1 kilometer resolution simply means it's a 1 kilometer by 1 kilometer square size. Pixel is a 1 kilometer by 1 kilometer square size. So once I click on the UN adjusted, I can search for any data that I want here. So these are the population density for each country and each year. So all I have to do is just let's say I'm looking for Nigeria data sets on population density. I just come to the search bar and type Nigeria. So here we are. So we have Nigerian data set from 2000 to 2020. So I might just pick just 2010 and 2020 data sets. So for you to download the data set from WordPop, just click on the data and resources, scroll down and access the TIFF format. So whenever you see a TIF format, it's a raster file. So raster data are stored in either GeoTIFF or TIFF format and other source or other formats rather. So just click on anyone you prefer. If you click on this zip file, there's a chance that you're downloading the CSV data, which is a vector data. So you can either have your data as a raster data or a vector data, but I'm more interested in raster data this time around. Okay, I've downloaded it before, but I'll just download it again. Just change the directory. Okay. So you also do the same for population density of year 2020. So in order not to waste our time, I'll just take us back to our QGIS and how to load our data. So you can load your data like we described in last class, or like we said in last class, you can load your data from any of these two. Either you load from this project menu toolbar, or you load from the browser toolbar. So because I have my folder here that I've started it here already, I will just load it directly from there. So I have the population density of 2010 and 2020 by 1 kilometer resolution. So if I click on this, double click, I have the data sets loaded automatically. So that's faster. Also, if I click on this for 2020 also, I have the data sets here. So one thing you need to know about raster data is whenever you load raster data, it comes in a single band color. So what do I mean by single band color? So what you are looking at here is a mixture of black and white, but because we have a white background, you might not be able to differentiate it that much. So all these white space or shapes inside the black background are also data set, are also part of the data set, raster data. So in order for us to make sense of these more, I'll just add OpenStreetMap to the background so that this makes sense more. So I think you can now see that it makes sense more a bit. So you have a mixture of black and white as a single band gray for the color of any raster data that you've imported. So if you want to make, or if you wish to make sense of this more, you can go through your properties. So a faster way to go to your properties is by clicking your layer here, your layer styling panel here. So although the normal way should be you right clicking and going through your properties here, but it might be longer for you. So once you click on your layer, it pops out as your right hand side. So I have my layer styling here, and I'm focusing on 2020 population density data. So the first thing I need to do is to edit the color band. So I can change the single band grid to the single band pseudo color. So you observe that we have a little bit of change in color here, and we can choose different band grids that we want. So let me just expand this. Okay. So we can always edit our layer also. Clicking on this min max value setting, it just is one of the features that displays how your data set have been distributed or have been shown on the QGIS. So what you're looking at here is a range of colors you're looking at here is showing the density of each area. So you can see the darker the color, the lower the density, and the lighter the color up to light blue, the higher the density. So another way just to edit your layer color is this, using cumulative count. So cumulative count helps remove outliers when it's styling your map. So it makes use of 2%, from 2% to 98% of the data by removing the outliers there. So you can see the change in the color here. So when we make use of cumulative count codes. So let's just do the same for year 2010, because this is 2020. So just to change your layer style in a year 2010, you don't need to go through the process. You can just click on your bar here and click on whichever layer that you wish to change. So let me just deactivate this layer. So if we do the same thing that we did to 2020 to 2010, we'll have something like this. Change the single band grid to single band pseudo color. and also change the min max to cumulative count points. Okay, so we have this. The population density for 2010 and 2020 now. We have the population density for 2010 and 2020 now. Just for us to see the changes between the year 2010 and 2020. I don't know if you can see what I'm showing you here. So once I unclick 2010, I'm having population density of 2020. There are slight changes there which are not really visible yet. So just to make this visible, and also to add locations to what we have here, because it's not making sense unless we add minutes to our data. So we can as well just edit our background map, which is the OpenStreetMap standard map. So for us to edit the standard map, we can reduce the opacity. So to reduce the opacity of OpenStreetMap standard map, just go back to your layer styling and come to transparency. I prefer to use 40% most of the time. So with this, you can see the label of OpenStreetMap showing the locations of each population density or of each area with the population density. If I zoom into Abuja, we can see that Abuja has a concentrated population density around this area. So let's observe the change in population density in Abuja. So I believe you can see the difference in the population density in Abuja between year 2020 and year 2010. So this is 2020 and this is 2010. So this is 2010 again, this 2020, this 2010, 2020. So one significant difference between the population density in 2010 and 2020 is the changes in color, change in color rather. So to better interpret this, we can also use a temporal controller, a special temporal controller. So before I proceed, I want to be sure that we are all following. Okay, so now just to record the change, also visualize the change.
Ṣé mo ti fọ́ ẹ létí? Ṣé mo ti fọ́ ẹ létí?
There's a nice. So just to visualize the change in population density between 2010 and 2020, we can make use of our spatial temporal controller. So to make use of your spatial temporal controller, okay, thank you. So to make use of your spatial temporal controller, you can right click on each data set. We are working with 2010 for now. So if you right click on 2010, you go to the properties. So you can see that the property popped up here. So on temporal, mark the checkbox on temporal. So you have your fixed time range here, and you need to set the time range of your temporal. So because this data set is a 2010 data set, my start date and end date will be in the year 2010. So I can edit my start date as, let me just use January 2010. And the end date will be December 2010. So click on apply. Also, you have to do the same for 2020. But before we proceed to 2020, notice the time or the symbol that popped out here after we checkbox temporal. So we are going to do the same thing for 2020. Switch to 2020. So from January 2020, then the end date will be December 2020. Always remember to click on apply. So now that I've not clicked on apply, you can see that there is no icon here. So if I click on the apply, the icon button comes out there. Okay. So the next thing is to come to your project toolbar and use the spatial temporal controller. That's the temporal controller panel. So once you click on the temporal controller panel, your screen becomes smaller. Then you can either click on the fixed range temporal navigation or the animated temporal navigation. I prefer to use animated this time. It gives you like you can see the changes. You don't need to be told. So using animated temporal, you can now set your features here. So you change the hours to either years or decades, depending on the changes you're looking at. But we are looking at the change between 2010 and 2020. So that's a decade change, not years. So we can change this to decades instead of years. Then it's just 1 decade. So for the time range, for the time range feature, you can either use auto refresh or auto select to full range, or you set it manually yourself. But I prefer to use auto select most times. So on using auto select, you can see that it brought out the time range from 2010 to 2020. So now, if I click on display button here, let me just switch this up so that. Okay. So if I click on display button of the temporal controller, you will notice a change. It might be very quick or too quick for you to notice. But one way to keep track of the change is to checkbox loop at the end of the control panel to your right hand side. So once I checkbox the loop and I click on play again, so you can notice that there's a change in the map. So this is just showing you the change in the population density between two layers. And my layers here are between 2010 and 2020. So the better way to give a vivid description to this. A better description for this, apologies. A better description for this is to add labels and titles to your map to give it better description. Okay, so how do we add labels and titles to a raster map? So how do we add labels and titles to a raster map? So you can come back to your view on your project toolbar here. Sorry for the breaking transmission. So, like I was saying earlier, come to your project bar here. You can click on view, then go down to decorations. So whatever it is that you want to add to your visualization to make it make sense, you can put it here. So the first thing we need to add is the title label. So once you click on the title label, you check box the title label also. Then you can now write your expression in this box, or you insert the expression with this button. Okay. So what I want to get, okay, let me come back here first. So what I want to get is I want you to know when we are switching from 2010 to 2020. So you go back to your decorations, title label, checkbox the title, insert or edit expression. So I need to get the map start time. So in this expression box, you can double click your map start time after searching for it here. So I need to get the map start time. I need to extract my year from the map start time. So I search for format dates, the map start time. What do I want to extract from the map start time? Just want to extract the year. So for the year, for me to extract the year is already signified by 4 Ys, just like we have the month and the dates also with years. So close the syntax. If I apply this directly, you should see the changes here because it's sent to the top center. But I don't want my label to be there. I want it to be at the bottom right. Okay. Click on apply. I can always edit the font. I can make the text bigger here. That's too big. Okay, so you can see the changes, the time series changes in population density of Nigeria from 2010 to 2020. So one more thing for you to add to your map, which is important, but it's not being mentioned enough, is your arrow bar. So you go back to the decoration from the view, and you add your not arrow. So this arrow, you enable the arrow and you click on apply. This arrow always signifies the position of your map. So if your map is structured in a north-south direction or east-west direction. Okay. So yeah, you have your time series map from Raster analysis, from Raster data. So this is just an example on how to reprocess the raster data. So now that you have your time series changes, time series visualization of population density between 2010 and 2020, you can always save it with export animation button, the temporal file. Okay. So before I proceed, I would like to ask if there's any questions so far. Okay, Said Olurebi said, is QGIS doesn't have OSM plugin and is the latest version. So if your QGIS doesn't have OSM plugin, all you need to do is just come to your plugins on the project bar, then click on manage and install plugin, and search for OSM here, OpenStreetMap. So once you search for OSM or OpenStreetMap, you can use your quick map service, then install the plugin. So I have it installed already, so that's why you're seeing reinstall plugin here. If you don't have it installed, you'll be having install plugin here. Take for instance, animate OSM. I don't have it installed yet, so you can see that it has install button here. So that's how to get your OSM. So once you install your OSM, just come down to web, and you have your quick map service there. From quick map service, you can click on OSM standard. Okay, now that we are done with raster preprocessing, let's make use of what we learned last week, which is on vector analysis and raster analysis system for a business use case exploration. Okay, so let's go back to our use case. Our use case scenario. So we have a use case here where raster and vector analysis are used for site location. So you can also call it next-best location if you prefer to call it site location analysis. So now, suppose a retail business has employed you to exploit their performance in a certain area, and they've provided the locations of their store. Now, it's your job to pick this data set and exploit the data sets and add a secondary data set in case you have any. So the large retail business in this case might be your popular ShopRite, Spar, or any other retail business. Okay, so you've been given a data set for you to explore their performance. So what we need to do is just to go back to our QGIS. Let me just save this before we continue. Okay, so we'll open a new file for us to do our analysis. And I'll remove this controller. So let's add our data. Let's add the data set that we got from the retail business. Okay. So these are the data that we got from the retail business. So they only gave us the data of their store and their competitors. So our job here is to explore the performance of their store compared to their competitors. So let's say you have a ShopRite, a company like ShopRite trying to explore its location analysis, and it has a strong rivalry with Spa, Obiano, and the rest. So our job here is to explore how that can be used to their advantage. So we need to add OpenStreetMap to the backend. So we can see these stores in each location. Just layer so it makes more sense. So definitely we are not going to use just this data alone to analyze or to explore this project. Other data sets we can use are the boundary of Lagos State. So all these data sets have been shared with you. So you just need to lay your hands on the data set and work on it later. So this is the boundary of Lagos State. And we'll be making use of the population data in 2020, population data 2020. Okay, so this is the population density data in 2020. Like I said, raster data always, whenever you import raster data, it's always come in a single band column. So you can as well uncheck it in order not to make a mess of your workspace. And just to this layer. Yeah. Okay, so one thing is common with this data set here. We can see that the particular stores are in just a particular section of Lagos State and not in every places. So it's majorly within here. So what we need to do is to get the map or extract the map that shows where these stores are located. We need to extract the polygon from Lagos State because this is the local government polygon shape file of Lagos State. So we need to extract where these stores are located in Lagos State. Okay, so to extract the polygons where these stores are located in Lagos State, all you need to do is just come to your toolbar once more and use your select feature button. So you can either select feature by polygon, freehand, or radius. So I prefer to use polygon most times. Let me just select features instead. Okay. So I can select this local government. So you can hold your control button while you are selecting the areas that you wish to explore. So as you can see, I've selected all the local government that I'm interested in, which is where the stores are located. So all I need to do now is to extract this local government out. All I need to do is to extract these local governments. And after selecting the local government, just come to something like this. So just come to your legal shape file under your layers, right click on it, and you can export it. Export your selected files or your selected feature instead. So I can call these LA focus I've been using. I'll just type here. LA. Yes, so I have my focus area in Lagos State. So these are the local government that I want to focus on in Lagos State. I would like to remove the inner boundaries by merging layers. Okay. So I have my LA focus area, and I have my focus stores and my competitors. So now the next thing now is to extract the population density of this area. So how do I extract the population density of this area? Remember that our population density is a raster file. So there is no way to just directly click on, oh, this particular layer, I need this, I need that. It doesn't work that way. So what I have to do when you're dealing with raster file, you want to extract the raster file from another raster data. You come here to the raster on the menu toolbar. Then you come to the extractions. So from extractions, you click on clip raster by masked layer. So once you have your masked layer, your input layer is a raster file, which is the population density. Then what layer do you want it to clip out with respect to? So I will just use my LA focus layer. And these other functions are not necessary, but it's advisable for you to input them. So if you know your CRS, if you know the coordinate reference system of your population density, which is 84 WGS 84 EPSG 4326 in mine, Then you can also move it to a target CRS if you wish to switch or to change the CRS while extracting the population density. Okay, so you can also give it a name. Let's start it. So I can call this LA focus population. So I have my focus population here. So I've been able to cut this population density from Nigeria's population density. Just zoom in this layer. Okay. So now that I have my population density, I have the competitors, and I have the focus stores, and the OSM map has been imported too. So the next thing to do now is to bring in the road. So unfortunately, we don't have road data because you might not be able to get road data accessible that way. So another method of getting road data is to go through by extracting from OpenStreetMap. So how do you extract road network from OpenStreetMap? So you come to your plugins, click on manage and install plugins. Then you can always search this toolbar for quick OSM. So because I have it installed already, so I don't need to install again. But if you don't have it installed, just click on it and click on install button here. Then you have it on your system. So once it's installed, you can just come to your vector toolbar and come down to quick OSM. Okay, so quick OSM is used to extract any shapefile you wish to get on OpenStreetMap. As long as it exists on OpenStreetMap, you can use quick OSM to extract them out. So go to quick query. So what do you want to query on? What are the keys you're searching for? Now, because I know roads are stored on OpenStreetMap as highways, so I'm looking for highways. So I can just go through each. So this is highway. Then what query value do I want? What type of highways do I want? There are different type of road network here. So if I want all the road networks here, all I need to do is just click on this blank. It's going to extract all the road network for me. And if I still need another data set with it, I just need to use this add or this plus button, input another query that I want. Let's say I need the street names, and I want all the street names. But in this case, we're interested in the road network, which is the highway. So now that you have your keys and your values there, then you need to specify the location that you're interested in. So because we're not getting everything for Lagos State, we're just getting for a particular set of locations in Lagos State. I'll try for Alimasho local government, an instance. So if I search for Alimasho, Lagos, Nigeria, scroll down and click on run query. So you have to wait for your data set to be downloaded by OpenStreetMap. Okay, so because of our time, we might not be able to download all the road networks, but it has been downloaded and shared with you. And if you wish to continue this process, so I'll just wait for this particular road network to complete the download. Then I'll show you how you can merge all the road networks together. Then we can move on to the next phase. Okay, we have overpass API timeouts, try again later, or with a smaller query. So in essence, what this is just saying is what we requested for is too big. So what we can just do is pick a smaller section of motion and request for it. So, okay, let me just do that again. To make it easier for you, you can add label to this local government focus, just for you to know the road network you're looking for. So you come back to your layer styling as usual. Make sure your shapefile is on the particular shapefile you wish to use. You move from symbology to labels. So click on symbol labels. Then what do you want the name of the label to be? So I can use admin2, which is the name of all the local governments here. So you can see Alimosho, Agege, Keja, Kosofe, Oko. So I'm trying to look for a smaller local government here. Okay, let's use Agege for the road extraction. So you go back to your vector, click on quick OSM, and your road query is IVs. You want all the IV in Agege, Lagos, Nigeria. Okay, yeah, fine. So we have Agege road networks downloaded already. So you can see this pink road network here. Let me zoom into. So these are all the roads in Agege. So we still need to get road networks for other local governments. But to make it easier for you, I've downloaded it. And if you wish to do this, you just have to repeat the process. So once you've gotten all the road networks you need, just match the shape files like we did in our last class using the vector preprocessing tools. Okay, so I'll just delete this in order not to waste much of our time. Okay. So I'll just bring in the road network data in. So these are the road network. So now I'm left with styling all my shape files so that this can make sense and make a meaningful representation. So the first one I'm working on is ELIF, that's the local government focus, the Lagos focus. So once on the Lagos focus, go back to your styling as usual, click on symbology. I don't want any color in the local government. I want it to be as transparent as possible. So you click on your fill style, which is solid, so no brush. Then I can as well increase the thickness of the outer boundary. Okay, I think that works for Lagos focus. So the next one to probably to touch on now is the roads. So once you click on the roads, Go back to your symbology, single symbol. I want the rows to be dark. Yeah. And also it's way too bright. Next, you need to come to your layer rendering. So that's where you reduce your opacity. So I prefer to use 40% most of the time. So I have 40%. Okay, now to my focus population. So I can also edit the focus population symbology by changing the single band gray to single band studio color. So this just signifies different population density. So the deeper the color, the higher the density. So we can see here we have orange. So this area around Moshin has a lot of high density, population density. This area in Agege also has high population density. So just to improve on that, we can use cumulative count or just leave it as min-max because we are still going to edit other locations too. Okay. Okay, so we have early focus stores. We have our competitors. We have the focus road, and we have the area that we want to focus on. So what we need to do is just arrange this properly first of all. So we can have this. So to differentiate between our business and our competitor, we can as well edit this focus store also. So to edit the focus store icon, just come to your simple marker here. Change your simple marker to SVG. So once you scroll down on your SVG, you'll be able to use different type of SVG. So I prefer to use this. And increase the size. Seven. And also change the color a bit. Yes. Okay. So I can do the same thing for focus stores of the competitors. So just to make it easier, I can just copy my existing style on focus store. And just copy my existing style on focus store and paste it on the competitors. Okay, but I need to edit my focus competitor so that I can differentiate between the business and the competitor. So I can change this color to something around this. Yeah, reduce the size also. So we can see from this from the map you're having, you can see where your competitors are situated and where your business are situated. So we can see that we literally have no competitor or business here. So this is a free space already. So the next thing to do now is to work on is just to reduce the layer rendering also. Yes. Okay, so now that we have all these and we have our roads also, we can also reduce the roads background to 40%. So what we have here is a visualization of where your business is situated and where your competitors are, and also your population density. So do we have any questions so far before we continue? Collins is asking for the legends of the population density. For the population density, just come to your layer styling, click on single band pseudo color. So once you click on single band pseudo color, come to the color ramp, it automatically gives you turbo, but you can as well change it to any other color ramp you wish for. You can decide to use this. Decide to use rocket, but I always prefer turbo. Okay, so from what you can see here, you can see where your markets or your stores are situated and where your competitors are situated. You can see this area, we have almost 3 competitors against just 2. And we can see we don't have any competitor here and we don't even have our business here. Well, we have just 1 competitor here. So now to move on to the site location analysis, So we are going to use what we have here to calculate the nearest drive time, because we need to capture as much population density as possible, because the larger an area or the larger the population density in an area, the more likely you are to make more revenue or higher revenue from the area. So what you need to do now is to go to your plugins once more and manage and install ORS. So this time around, we are using Open Route Service. So you can call it ORS or Open Route Service. So you can see that I've already installed So all you need to do is just click on this and click on install. So it's called ORS, Open Route Service. So what ORS does is to give you an estimate of the drive time or the closest way to get to your location, whatever location that you want to work on. So what ORS do is to compute all other layers that affect that location and give you the estimate. So now that you've installed ORS, you need to go to your browser. Okay. So you need to go to your browser, then you can either search for ORS or Open Route Service. So you sign up on Open Route Service. although I'm signed up already. So you need to sign up on Open Service. I'm signed up, so I just need to log in. So once you signed up on Open Service, you automatically have an API key here, or if you don't have the API key here, you can as well just scroll down to request for a new token. So once you click on create token, you automatically create a new token, or you input your token type and your token name here to create a new token. So once you have your API key, you need to copy this key. So once you've copied this key, you go back to your QGIS. Once you are back in your QGIS, you click on web, then you have your ORS tools here. So you click on your provider settings. So once you've clicked on your provider settings, you have to input your API key here and the base URL. So the base URL is just api.openrouteservice.org. So this is what you'll be connecting to on the back end, to the Open Route Service website. Then you input your key and you click on add. You do the same thing for ORS here. You input your key and your base URL, then you click on add. So, okay. So now, for you to make use of your ORS map, or ORS service rather, so you come back to your web and you click on ORS tools. So once you click on ORS tools, on the ORS tools, you have sign up resources for then the provider is ORS, Open Route Service. And either you, depending on what you want to do, if you are working on just directions alone, you can use just directions. But if you are working on trying to get the estimated time for a location, click on batch jobs. So once you go to batch jobs, click on isochrones from layers. So if you are using a point data set or a vector data, which is a point data, you can use isochrones from points. But because our data set is a layer, so we have to use polygon. Sorry, because our data set is a polygon, we have to use layer. So once you click on layer, you have your provider as Open Route Service, then the traveling mode. So you can either look for a driving distance of a car or driving distance of a vehicle's duty vehicle, or if it's cycling, or even if it's walking or wheelchair. So how long it will take. So here we'll be using driving distance of a car. So the driving car. So what will be our input points layer? So we need to focus on our stores first. And then input ID, which is optional. And always use this ID name. So the time. So here you can either pick the time or the distance. Is it the distance you want to calculate, the distance to get there, or the time? So I always prefer to use time because I'm just okay with time over distance, because at times it might take you faster to get to a place and you'll be able to calculate that. So once you use your time, what I want to do here is to create a time range between 3 minutes and 5 minutes. How long it will take between 3 minutes and 5 minutes for the distance to be covered. Okay, so you can always save your isochrones. So save to layer, save to file. So I can call this LA store driving distance. And it's saved into your package. So all I have to do is just run this. Remember, the moment you click run, you are hitting an API. So you need to be careful whenever you are hitting the API. So you need to give it a rest time. So once this is done, if I run another one immediately, I might run into error because I've not given the API a rest time. So what I need to do is just to close this. You can see from here, you can see a lot of isochrons, or what I call them polygons, around your business focus points. So what you're having here is the driving distance. If it's going to take 3 minutes or 5 minutes. So the smaller isochrons here, which I will just check for you, is for 3 minutes. So these are 3 minutes distance. So this is a 3 minutes distance, a driving distance, while the bigger isochrons is 5 minutes distance, driving distance. So for this particular store, it will take, for this particular store, for the people around this particular area to get to this store, and with the road network around it. So these are the people that can get to this store within 5 minutes of driving distance. So this particular store is catering to, or is servicing this population density in this area. If I right-click on the shape file, or the layer rather, and open the attribute table, I'll be able to see the population density for each driving distance of each location. So for this particular location, this business location, which is BO, let me see if I can highlight it on the map. Trying to see where it is. Okay, yeah. So BO is a B0. So it's servicing in 5 minutes. It has access to 36,331 population per area in 5 minutes. While the same location in 3 minutes, it has access to 11,834 population per area. So it means the people here can get to this store. The people here can get to this store in less than 3 minutes. While the people here can get to this store in less than 5 minutes. Okay, but this is looking modeled up already, so we need to structure it well. So you go to your layer styling as usual, which is the driving distance. So your driving distance is automatically categorized because you're using 3 minutes and 5 minutes. And this is the value it's using for the category, which is the driving distance. So for me to edit each driving distance, so I will just have to click on the driving distance category, which is the 3 minutes, and also try to reduce the opacity. Yeah. Okay. So this is still highlighted because I've not removed the highlight here. So let me just toggle edit and then cancel this. So we have our driving distance of 3 minutes and 5 minutes to the store. We have our driving distance of 3 minutes and 5 minutes to the store. So now we need to do for our competitor. So now that we've gotten the driving distance for our business, we need to calculate driving distance for our competitor. So the same way that you did for your business, you do for your competitor also. So just click on the web, go to the ORS tools, then use your batch jobs, use the isochrones from layer So you are using traveling mode, which is car, and open road service. So your input point layer now will be different. So instead of using stores, you are using competitors this time around. And you are going with your layer ID, which is the name. So also, I usually make this mistake, and I don't think it's actually cool for you to make the same mistake. Always remember to save. Like now, I've not saved at all. So if something happens along the line, I might not be able to retrieve what I'm doing. So I have to save after this call. So now the time has been set. I need to edit the range again to 3 and 5 minutes. Okay, so I have to save the layer. I can call this LA competitor driving distance. Save, also run. Okay. So let me just quickly save this. So, okay, now that my work has been saved, we can continue. So let me just uncheck the store driving distance and focus on the competitor's driving distance. So for the competitor driving distance, you can see a lot of polygons also. So we have that of 3 minutes and we have that of 5 minutes. So this is for 5 minutes for each competitor. This is for 3 minutes for each competitor in the area. So another thing we can do is just to style our map or our layer. To style our layer so that it can be effective or informative. So all I need to do is just to come to this layer again. I'm focusing on computer driving distance this time around, and it's categorized picked 3 minutes. Then I can change this color to say, yeah, let me use something like this and reduce the opacity. So I can just copy this and paste it here. The same. I'll give it a little bit like that. Okay, so now that we have our completer's distance of 5 minutes and 3 minutes, we have a focus of 3 minutes and 5 minutes also. Now we can see, so let me just use 3 minutes drive for both focus store and completer's distance. Okay, let me try to increase the visualization of the focus store so that we can see what we have on the map clearly. Yeah. Okay, I think this is clear enough. This is clear enough for 3 minutes. So what we are having here is a 3 minutes driving distance between our business, our focus business, and our competitor. So we can see that none of them are actually focusing on this side, even though the population density is very, very low in this area. And none of them, or our competitor is actually lagging in the our business is actually lagging in a highly dense populated area. So these are some of the few inferences we can make from this map. I'm not comfortable with the color of this isoplane, so I'll just switch it up again. Okay, so this is this. Okay, so this is for 3 minutes. I also copy the color. If I want it for 5 minutes or so, I'll just have to paste the color. So this is for 3 minutes. Let's focus on 5 minutes distance. So in 5 minutes driving distance, we can still see that none of them is still getting this area. And our business is actually lagging a lot in this area. It's lagging like a lot. So this can be our inference from this analysis. So what you need to do now is to extract your map. So how do you extract your map? We learned that from the last lesson on how to extract map. Just come to your print layout, new print layout. You can call it any name you wish. Print layout. So you add your item, which is the add map. Here we have our map, and we can always add any other thing that we want to it. The first thing I always add is the north arrow. I always want to emphasize on the position which my map is facing. So after adding the north arrow, you can as well add the legends. So you can add the legends at this corner. Apologies. You can add the legends at this corner. So once you add the legends, you need to remove the auto update of the legends. So once you remove the auto update from your legends, you can delete all other stuff that you do not need. So I'm deleting focus road first. We're getting this, don't have to delete it also. I have my focus stores and my computer, so we can still edit the focus store name to business. And also edit this to computer. Okay. So we can always add a title to our map. For you to add title, you need to be able to insert text, which is what I'm looking for. Yeah, add label, sorry. It has to be add label. So you can add a title to our map and put the label here. So you can call it sites. So we have to edit this, obviously. And change the font to font size has to be bigger, obviously. Let's make it 20. Let's make it 25, 27. Yeah, this is okay. We can have it at the center can be in the middle or at the top. I just want to change this to bold. Yeah. And I always prefer to have the inside as white. And then I'll come back to rendering. And that rendering. Background color. Trying to outline this. Okay, this is for the frame. Okay, so I can't seem to get the outline. It's something I can always look for another day. But anyway, so this is your site location analysis. This is a site location analysis. And with that, you can always extract your map. All you need to do is just do some edits on this. I always like this to be bold. Okay, so that's that on site location analysis. So we can see from our map here is lagging. We don't have our business here, our computer here, and our competitor is actually beating us at a very dense population area, which is around. You zoom in, it's around Mushin, Shomolu area. So now what you need to do is to print your layout or export your layout as image or FBG or PDF. I always prefer image. I use it anywhere. So I can call this site location analysis just PNG. Yeah, resolution. Okay. So that comes. Okay, so we have our site location analysis image extracted, and we have our analysis. So if I wish to compare just 3 minutes alone, I can also do this for 3 minutes and see how they are faring. So if it's an establishment that I wish to have more locations, I can always use this 3 minutes and see where we are lagging. So we don't have access here, we don't have stores here, we have obviously here, and to the extreme of course of there, we really don't have reach there. Okay, so just to summarize this class as a whole, we've been able to understand what the raster data, raster layer is, and we've been able to load raster data. We've been able to pre-process raster file, which has given us an animated GIF, and we've been able to use our vector and raster analysis to solve a business use case. All right, so that comes to the end. That signals the end of the class. So if you have any question, you can just let me know by putting it in the chart window. So Collins said, how do we add legend of population density to our map so that someone looking at it will know high and low population areas? Okay, just like the way you've added other legends to your map, let me just go back to the print layout. I'll just make this quick. Add map. So the way you've added your other legend, add legend to your map, all you need to do is just to uncheck the auto updates, leave these, you're deleting these. Oh, sorry, need to add it again. So uncheck the auto updates. Okay, so we are removing this. Highlight it. We are removing the computer driving distance also. We are leaving this. We are leaving the early focus population density, although it can be renamed as well. But since that's one of the legends that we care for, we have to leave it on the map. Okay, so once you have this on the map, you can as well edit the name of the population density. Although I could have used maybe 3 categories, but if I use 3 categories, you won't be able to see the difference in the population density. So what you can do here is to, if you want to remove the early focus population on it, so you just need to set it to hidden. There you have your legends out here. So this is one of the reasons why I did put the focus population in here, because there's so many legends. I just put the range from the low to the high. So that's that on early focus. Then you can print your layout as usual. Okay, let's check if we have another question. So how can you use it to know the computers in mining industry? As long as you have your data sets, as long as you have your locational data, we can always use it to. You can always reproduce this with your mining industry, in your mining industry. What factors affect your mining industry? What are the factors you are looking for? And who are your competitors in the mining industry? So once we have all these details, you can as well reproduce what you have in here. Okay, I'm thinking, so Colin said, I'm thinking if there is a way to categorize the legends. I'm not sure I understand your question, but there are definitely ways to categorize legends. So, if you're working with a raster file, you should be careful of your classification. Because if you probably reduce or shorten the legends way too much, or you squeeze your raster file way too much, you might not be getting a meaningful insight. Low, medium, yeah, that's what I'm saying. So for you to do the low, medium, and high population areas, just come back to your file here and click on your population, your layer styling. Go to your layer styling, click on the shape file, which is the early focus population, and you're using single band pseudo color, min max. So what you can do here is to come down here and as well remove or delete this. So you have to change the mode from continuous to either quantile or equal interval. If you want it as equal interval. And if I don't want classes, like if you said low, medium, high, so let's just reclassify into 3 categories. So this is low, medium, high for you. So you can see that this is not making sense as much as what we just did. But we can always edit it also. We can always reduce the opacity, edit the color, and things like that. So this is just how to classify it. So how do we get the data used? And all of them, because once you go over it again with the recording. Okay, for you to get it, the data will definitely be shared after the class by the competency manager. So they will share the data in the Google AI Classroom. I don't know if they are using the Google Classroom, but it will definitely be shared with you. So with that, I think that signals the end of our session today. Thank you very much for coming, and I hope you practice this on your own. So there's a question from Abirama. It says toxic release inventory preliminary data contains data about chemical release and waste. Okay, I think this is just normal conversation. Okay, so thank you very much for your presence. And right now we are about to end this session.
Hello, Teju. Teju, are you there?